So we kind of have what's considered a definition or an undefinition of multifamily. It's mostly all about existing structures, although you can apply this to new compliances also. I'm not going to be digging into how to follow any specific standard. It's more kind of an investigative approach or compartmentalization, which is how to isolate a single unit from other units. Common construction defects or diagnostic testing. What all can you actually do in a multi-story structure with even just a gauge can actually be very beneficial, determining a lot about what's happening. So a general definition of a multifamily is a building that contains 5 or more dwellings, whether it's straight up, horizontally. Usually they have multiple or interconnected HVAC systems or a variety of ventilation that may be all connected, or they could still be independent. So if you have a different definition of what multifamily is, please go ahead and throw it up on the question so I kind of can make sure I'm coming from the same background as you, or understand some of your different concepts that we want to make sure I include today. It doesn't have to necessarily be a height issue with a multifamily, because there are several that are all ground floor but are all connected as a multifamily structure. These are some of the most common resources that are out there that many people are aware of that come into play with multifamily. Multifamily and large buildings start to merge together depending on how you're going to test the structure, whether you're going to be isolating individual units or compartments, or are you going to be trying to test the whole thing as an entire structure. Our understanding is there's not that many people that are testing the entire multifamily structure. So if you are doing that, let us know, because I want to make sure I adjust, again, some of the language to cover some of that. So again, many of these you're familiar with, but Building Science Corporation is a great resource for how-to guides on all things we're talking about. So under resources, though, I moved this to later into the actual meat and potatoes, is that there are, under the support pages, where you can also find these articles and papers, and many of which I tried to include in the handouts that you can download. So in your little control panel, you have a section that has handouts, and you can download. We can upload 5 at a time. So I uploaded 5 that I felt were pertinent. But if you're looking for more articles and papers, those are actually in this section right here, because I only did 5, and I can tell you that there's more. So under the support page down there at the bottom, you can actually find great information about our topic today. And these are some of the ones that are out there that you have access or did download. I did not include this energy assessment protocol, but you can download that from the Retrotec website. I'm not going to be referring to or dealing with ventilation at all, because that's just a hot topic, especially with multifamily. But if you're looking for more information, we always promote Rick Karg and his great online apps that he's got out there. So you can go to residentialenergydynamics.com. They call it RED, but again, residentialenergydynamics.com, and he has some phenomenal resources about whatever type of ventilation or testing methods you may be doing. He's got an app online to help you resolve that. So this is actually an older version, but it's still, I'm sure, it's still pretty applicable. In fact, I believe that the multifamily in some areas has gone up. I was looking for slides that I'd had, and I could not locate them again, but there's parts of the country where multifamily is booming. Georgia's one of them. Much of the Northeast has got some of that. So there's some areas where multifamily didn't really have a big boom since our last housing crash, but other places it's actually a significant number of permits are being applied for the multifamily. Everywhere I drive around here in Atlanta, I see just numerous multifamily structures going up all the time. So it is something that's becoming a strong resource for the housing community in terms of getting probably the better bang for the buck in terms of the amount of people they're putting into one spot on their land. So this is trying to show you that there is a large percentage of multifamily that's actually occurring. And you can also go to the National Multi-Housing Council. They have great information and probably some more information that's been updated on this. So I do have a link that I can actually respond to. So I'll pick a simple question here of I can hear you clearly, and I'll send out here command. This is the link to the air leakage and testing of the multifamily units that I have on site here. So I'll send this to all. This is a great article that actually kind of goes through. They picked 3 cities, and they went through and they actually did some improvements on each one of these and tried to explain. Some of them had heat pumps or electric furnaces, and overall, what were their savings per year? And you can see that there wasn't anything to write home about, but these were actually significant in terms of uh, these families themselves. So, in Indianapolis, to save $235 a year is actually a significant saving. So, this whole PDF document has a lot of great information about the slides that I have here. So they have a conclusion that that there is, even if it's over 20 years, that are a great opportunity for savings compared to other housing types. And there's lots of things that make them very complicated, and that air leakage should be addressed between units or in general, because they felt that was one of their most significant issues in terms of reducing the energy costs. So energy bills or green business model. So this slide here is trying to explain to you. Over on the left is the leakage per CFM at 75 pascals per square foot. So this is leakage per square foot, not in terms of the area that we think of as the square footage of the floor, but actually the entire area of the structure itself. So it's actually square footage of all 6 sides of the model in general. So the 0.25 has been the general goal for the Army Corps and many others to try to achieve, which means that your energy bills or your air leakage or infiltration is becomes small, and basically the environment becomes very manageable and controlled. 0.4 is what they're using in Seattle and the Washington State as one of their compliance models right now for testing, buildings that are 4 stories or higher. So the other ones are just kind of model numbers that have been out there, or you kind of can compare that if you're at 2 CFM per square foot at 75 pascals, that you really have a significant amount of uncontrolled and severe leakage, which is also causing high energy bills, comfort issues, and a variety of other conditions. So one of the things that does happen when you start getting to larger structures, they deal with, again, CFM per square foot of the surface area, versus doing air changes per hour. And when you start dealing with multifamily, it kind of can mix into both of them, depending on if you're talking about individual units or if you're talking about your method of testing, which may actually be CFM per surface area. So one of the things we want to do was to remind people to make sure they're very familiar with the location before they test. It seems like a no-brainer, but suddenly something pops into your vision when you're actually there at the test with a bunch of fans trying to do something that you did not realize or see prior, that you want to make sure you've covered all of those areas and what is behind door number 3. And if you don't know, then you're going to have a hard time maybe completing your test that day, or make sure you have access to it. So access to adjoining units or mechanical rooms to find out if they're part or connected to your air barrier, depends on the type of location. You definitely want to have your building engineer or owner or manager not just make sure it has gone through a walkthrough with you, but there that day. They actually are a representative of the structure of the building and can help overcome some of the challenges, especially the engineer who can open doors for you or make sure things are off that you have to have off in order to do your testing. Because you want to make sure you have access to some common areas, or at least know what's on the other side of that door, whether it's actually going to the outside or is still part of the enclosure or a conditioned area. And I highly recommend you document what you do have access to or what you cannot. Some places are like, oh, we can't go in that area. That's a secured area. And they may actually be impacting your test results or not, but you must make sure you document those in your report so that you could be reminded that we didn't even have access to that half of the floor. So it actually may have impacted your test. When you're going to do, depends on the area, you would know the area in general, but to come up with a multilingual sheet explaining, hello, my name is, and today I'm going to be doing, a blower door test, and kind of explains us where I need to go into your unit, and or not, or maybe it's just actually having the the front door open so I can test the unit next door. It does help a lot to have badges with pictures on it, or at least some kind of badge with a identifier of your company. All those things help folks who are in these individual units as their homes to actually allow you to come in. So a letter ahead of time is especially something that's from the owner or manager, as you know, would make a lot of sense. All these things make your day go very smooth. Without them, it can be a very challenging scenario, or if they're not home that day. And do you really have access to get their unit opened or not? So, and also really making sure that's why the engineer's around, to make sure you understand the HVAC system, and is it independently controlled for that unit, or is it a common system? Is it into the common hallways? If I need to have it off for my testing, how do I actually make sure that gets conquered? Clearly, I can't do it on a day when it's 0 degrees outside. And the last one is power. It's always one that's forgotten about, and that is, do you have enough power to get you to where your fans are going to be? And if I'm going to have 2 larger fans, I may need to have 2 independent circuits to make sure that I'm not overloading a circuit. So that's a common challenge to do that, and realize that one is almost maybe 75 feet away, and I should have a large enough cord to do that. So again, we're not going to really focus on be it Energy Star or LEED or ASTM standard. You can download the Army Corps of Engineers for free. So my goal is actually focus more about how to do just general diagnostics about pressure mapping when you're in the unit, or when you're in the hallway, or in the structure itself. Like, what can you learn about the kind of pressure diagnostics that are happening in the units compared to the hallway compared to the stairwell, all of this also compared to outside. So sometimes you can actually just go down to the stairwell and prop a door open, and now I actually have access to outside, versus keeping the door closed and understanding some of the pressure issues that actually happen when I have an enclosed area that's 3, 4, 5, 25 stories tall, actually affecting pressures inside the unit itself that also impact the common hallways and impact my individual units. So we recommend trying to do a method of where you're actually maybe testing the boundary high and low. Those are your best way to get a good pressure map. And that actually helps me determine whether or not I have issues that are only on the bottom side or top side, or my pressure differences are. Sometimes that can be challenging if you have some type of fire stopping framing in between them. But in general, if you're going to check one spot, it's great to go around a room and kind of create a basic pressure map. Some of these things are not able or can be completed if you're going to do this on a really windy day. You may have a large temperature difference or a huge stack effect that's happening, so you got to make sure you're aware of that. And tubes are affected by the temperature in the sun. So if you actually have one of your tubing that's going all the way down the stairwell and a whole bunch of it sits outside in the sun, that these things are going to impact your readings. And then next thing you know, that the sun has shifted as you're going to be there for the whole day, and you wonder why my pressure's just shifted, because your tubing also has an issue. Colin, do you want to comment on some of the things you guys have with tubing or other issues with that? Do you have something you can add to this?
Yeah, the one comment I would make there is that the tester needs to experiment with this thing to actually take one of their tubes, move it around the building, and find out, for example, that if you took the tube from the first floor and carried it up to the third floor, there's no difference at all. However, if you have that tube and you expose it to the sun and you allow the temperature in the tube to be different from the temperature inside the building, then you'll see quite a significant pressure. It could be 20, 30 pascals. Similarly, if you take a tube and you chuck it out the window on a cold day, the air in the tube will be warm, and initially you'll see quite a big stack in that tube that could be, again, 5, 10, 15 pascals. As the air inside the tube cools down to the temperature of the air outside, then that tends to go away. The important thing here is whatever you do, whatever procedures you follow, you need to experiment in isolation so you can see how these things will affect your results. So that would be my biggest tip, is to experiment.
We also discussed recently about the color of your tubes. Can you extrapolate briefly about one of the things you did by accident, your red tube?
I'm not quite sure what you were thinking about there.
Wasn't it a UV issue with you guys have solid tubing in general?
But, yeah. Yeah, one of the reasons why we use a red tube outside is that anything that's red reflects infrared, which is heat that comes from the sun. So a red tube tends to heat up to only a third as much as, say, a blue tube does. So that's one of the reasons why we chose a red tube. We'd like to find a silver, a tube that had a silver finish to it so that it actually reflected all the heat, but so far we haven't been able to find one. But the other reason why we use colored tubing is that if we have 5 or 10 gauges and we have them all hooked up, it's hard enough to follow where things go anyway, like without having, by having the same color tube, it makes it much, much easier. So typically what we will do is we'll bring in the red tube from outside and we'll manifold that so the same pressure tube is being applied to the red port, which is the negative port of each gauge on channel A. We have excellent diagrams in our multi-fan manual on these things, so if you're doing one of these tests, you really should get a copy of our multi-fan manual from our website and go through it. Back to you, Joe.
I believe that's one of the documents I put in you can download. So hopefully that is. Reading through a couple of the questions here real quick. So in terms of how to get the Army Corps of Engineers, the easy way to do it would be to just Google it. I didn't have a link. I apologize, but it's easily found through Google. And I'll let there's a couple of the questions I know Colin's in the background. He can dig into about stack effects. So here's a diagram that I kind of made about. Again, this is definitely a high-rise type of structure, but this is also multifamily in general. So one of the things you can actually be doing is confirming if whether or not do I have connections from my unit to the hallway. And one of the things that happens in these units is their ventilation system. Their ventilation system is, which will be changing soon, but right now you have a ventilation system that's running down the entire path. You may have 2 or 3 depending on how tall the structure is, and they're trying to complete all of the bathrooms or connect all the bathrooms as a slight negative pressure all the time, 24/7, because most people no longer have their own individual fan or even a booster. So that's a major impact that happens throughout the entire structure, and it can be a significant, a measurable number that can happen. So that's one thing that is occurring. And then the stairwells themselves are usually on a negative pressure also. So in your hallway usually is on a positive pressure. So there's all these pressures that are actually very dynamic and happening throughout the structure in general. So one of the things you really want to make sure of is that you can go through just with your gauge alone and determine if you have what kind of pressure differences I have between, again, the unit, the floor, the common area, and the stairwell, and even also down to outside. So you can determine a lot about how the structure is actually working in its natural condition, which is hard to do on a residential structure in terms of the type of pressures. And if there is a parking garage down below, this is one of the things you're really trying to find out if you do have a connection to. So even before you're able to test, a lot of times you can actually determine if the parking garage compared to just a few flights above, if there's a positive or negative connection. So again, all these things can be done by just doing some detailed diagnostics with a single gauge throughout the structure. One of the other tests which we're going to talk about is trying to separate unit to unit or floor to floor and more of a compartmentalization test. So I thought I'd try and illustrate that now. And I guess one of the questions is that, is there, when you're testing, you want to make sure we're clear on if we're doing surface area versus volume. There's still a lot of multifamily units that are out there that are doing IECC code compliance, and they still do air changes per hour. And that gets very difficult with a very small unit. So some places are altering their method. I believe New York was trying to alter their method to go from an air changes per hour to actually a surface area. So I know there's a few folks from out there. Michael, I see you're out there. If you have something you can give us some more information on, that'd be great. So in terms of most of the leakage areas, it's a lot easier to determine how leaky the structure is when I'm using surface area for these smaller units. It's a much more accurate and much more defined way to determine what my conditions are. Multiple different ways to do these types of testing. So I'm mostly going to focus on those who are doing compartmentalization or doing the smaller part, the smaller tests, which are single units, and trying to isolate them from one to the other. So these are some smaller ways to actually isolate units that are adjacent. Sometimes you can just get away with a duct tester or maybe even a duct tester in the window. So on the right is actually the passive house frame and cloth that Retrotec now has to do a duct tester test as a blower door method. So how many fans and locations? Again, if you're going to do the corridor testing or if you're trying to do the whole structure, that becomes more of a large building or a multiple fan type of a test. End of August, we actually had a nice webinar on that. You're welcome to go to YouTube to kind of get more brushed up on that. There are a lot of issues with where's the tubing go and how fans can be battling each other. So my goal is mostly to focus on some of the challenges you may have with smaller tests that you do with multifamily. So there, you can download a number of fans calculator. So my goal was trying to be a little more, cover those who are testing larger areas. But in general, the focus in a minute will be more on compartmentalization. Oh, you can download this now. Actually, it's on their list of documents. So when I first did this, we had to send out the link, but you can actually download this on under the support under their documents area. And how are you going to be connecting your fans is another common question that comes up. So it depends on maybe what software you're going to use, or if you're only going to be doing testing single units. Some of that can be done through Wi-Fi. Some of that can be done through Ethernet or USB because it's a short range that you're probably close enough that you can actually just use USB. If you're using the older gauge, the DM2, it only uses USB, so you're kind of are challenged by how far away you can go with the gauge to your computer if you're going to use some kind of software. This was a general rule for those who are doing, more of the whole building. That if it's on or operated all the time, you just kind of leave it in its natural condition. You can turn off if it's a fan system or something that's intermittent. You can cover the opening. So most of this comes into play with the soon-to-be-released ABA standard for testing air tightness compliance method. And their goal is to come out with something that's designed to be considered a air barrier, which means I close off the entire structure or normal operating conditions. So I looked for it on their site today. I did not see it, but this is where they're headed in terms of trying to give really good guidance as to what gets covered and what is left open. So while we're doing some of our testing, there's a variety of things that we can also be doing in terms of finding the leaks. Many people ask me, what's the best smoke puffer to use? And I usually tell them it's the back of their hand because you always have it with you and it always works. But if you are trying to do something that's a little larger in terms of, you can actually pressurize the structure and then go outside and find where these leaks are occurring. That's actually a very powerful method for these types of buildings. So the infrared I have here, which is from Phil Emery, it's a great photo because it shows everything all in kind of one shot here. So it's showing us, if we start on the right of his picture, he's showing us where I actually have thermal bridging because I can see I have insulation installed in the wall and I can see the thermal bridging with the studs. The section in the middle is missing insulation, so I clearly have a problem with missing insulation. And on the left, it's actually showing the air leakage that actually occurs. So I do have insulation, I have some thermal bridging, but I have significant air leakage at the bottom. And you can see it feathering up inside right next to the studs. So this is a great shot that kind of shows everything all in once and why using the infrared while you do your blower door can be very informative. So these are some of the mechanical pressures that are happening. So if you look at the illustration on the left, basically we're talking about the kitchen, bath, and bedroom. So these are all my ventilations, this is a exhaust only type of a system. Sometimes this may be individual units, which I think most of these multifamily units are going to be going back to, versus actually something that is a single source throughout it or has its own ERV. Again, is where I think more people are going to be thinking about that they have to do that. The 62.2 rules are beginning to change and trying to isolate individual homes from commercial common areas. So, again, you can see some of the plays that actually are happening in terms of the pressures you might be trying to evaluate as you're at that structure. So most of these things all have a neutral pressure plane. Depends on the conditions or the issues that are happening within that structure itself. I was out of North Carolina a couple of months ago, and I was in a hotel that had the parking below. And right by the elevator and the stairs that went up was their really large fan that was their exhaust fan. So I was surprised to see that these things are all happening in a very centralized area, in terms of trying to pull air out and other things that are naturally moving air from the stack effect with the elevator. So they do have a very large opening on the far end where the cars come in and out. That's open all the time. But if that's on a windy day, you definitely have an enormous amount of air pressure moving to this one centralized far corner and sending all of these pollutants straight up into the structure itself. So that's one of the things that is actually a common issue that you are want to be doing the diagnostics with is, are these areas that have a common garbage chute or elevator to a parking area connected to the area that's living above there. And you can see that there's a variety of common issues that may be happening when I do have a central exhaust system on how to apply those kind of pressures that might be occurring while you're trying to do your test. Here's again another one that's actually trying to show what happens when you have various pressures when you're doing the test itself. So it's hard to see, but right down here in the bottom, we actually have our little set of blower doors happening, and they're trying to pressurize the entire structure. And then I can actually, try and do a measurement or confirm what my total leakage is. So this is a total structure type of a test. So some people may be doing this with multifamily. Again, it's not that common from what our understanding is. The other one that you also can do, instead of doing the total leakage, you're now going to be dealing with individual units of leakage from unit to unit, or even just a unit by itself. Whether or not you're going to find out if the unit has a certain amount of leakage is going to really, you want to also try and determine if it's leaking to the unit to the left or the right or top and bottom. That actually gives you an indication of how these units are connected together, which the large total building test does not do. The large building test just really tells me if my exterior skin air barrier is working correctly or has some flaws. It doesn't actually tell me if I'm leaking floor to floor or unit to unit. And when somebody moves into unit B and finds out that somebody in unit A liked to smoke cigars, and the guy in unit C on the other side went in and put in a 1200 CFM super kitchen exhaust fan, that the person in the middle ends up smelling the cigars because that air is going to be pulling right through one unit to the other. So there's several test methods or test protocols you could be following. There's a single unit. We're mostly going to focus next on the neutral pressurization test, aka also called the guarded test, where we kind of create pressures on the adjoining structure to determine the leakage to that side, and then I can determine how much of that should be focused on in terms of repairing it or correcting it, or if there's actually issues that can determine that this unit itself has so much leakage because I don't get to count the units to the side. Multiple fans and multiple units simultaneously is a whole nother concept, and the building as a unit, as I mentioned, is something that some people may be doing. I'm assuming the sound is out there. Somebody else said they lost sound. Hopefully the sound is still good. Anybody else lost sound? Sound? Good, still good. Okay, a couple people say it's still good. Thank you. Okay, so the test method I'm going to go through now is how to do more of a compartmentalization test or the neutral pressurization test. Basically, we want to create pressures on the adjoining side to determine leakage to that side by actually just separating that leakage can't happen. So if I have my individual structure here, I have one on the right, I have one on the left. My goal is to find out what's the leakage of the unit in the middle. There also could be leakage to the outside on the back, or it could be leakage to the hallway in the front, or leakage to outside in the front, depending on how this structure actually was designed. So the most common test, which is very familiar, is we just test something big or individual unit by itself, right? So I now want to actually focus on how to test a single unit from the different sides around it and actually the floors above it and below it. So this is the overall view that we want to do, is actually be able to isolate this one unit in the middle and isolate this one unit from the floors above and below it. So in order to do a compartmentalization neutral pressurization test, is I'm going to start with unit A, and I want to test unit A. We'll assume that we're just going to focus on what's the connection or relationship between unit A and B. So when I do my blower door test, I'm going to you can pressurize or depressurize, but right now I'm going to pressurize just because I think that makes the example a little more easier to follow. So as I'm pressurizing unit A, I'm able to get a reading on what that is. But the challenge is that at unit B, that if I don't actually put a hole in unit B, like crack a window or open a door back up, that area will end up pressurizing itself, and it actually puts a barrier between unit A and B itself. So I must have some pressure relief in the adjoining structures in order to confirm how much leakage is going into them. Otherwise, especially if they're very small, they just become an actual barrier themselves. So I have adjoining structures. I'm cracking the windows, or I'm opening a door, so I know I have some kind of pressure relief in general. Now the other option is now I can actually put another fan in the unit B and either do 50 pascals, the same as I'm doing on unit A, or I can actually make it go to 0, which actually means I'm going to tap into channel A's pressure. But the goal is to actually isolate channel unit A from unit B, and I can also do anything that would be on the left or above or below. Then once I have equal pressure, I no longer have any air leakage through unit A to any other units. So I have a couple of illustrations to still do that real quick here. So yeah, some people say that there are several. The ICC does not allow you to do a guarded or neutral pressure test. It just says take what you get from this one unit. I don't care where it leaks. It's just leaking. So I understand that that's actually one of the challenges that is out there. So yeah, he's asking about creating a pressure relief. So should I try to get the units next to me if I'm going to do a single fan like I'm doing right now, right? What you're trying to if you're after I would actually follow what the guidelines are, because whenever I'm dealing with a code or similar situations, I would want to find out what am I allowed to do to the adjoining structures. So if you open up the adjoining structures, it could make your unit appear leakier because I now have an area for that pressure to go to. So if you were to consider that I'm testing under normal operating conditions, then usually the unit next door may also be closed up like I have this one, and that may give me an easier compliance number. Or if you're after what are the leakage to the units next door, then you're actually going to do some kind of pressure relief on the adjoining units. So hopefully that was some guidance. I would see if there's some kind of clarification to your code to do that. So he's asking also, these are great questions from Jim Nugent, is do I test to the outside or to the enclosed hallway? You always are trying to test to the outside. That's always the pressure that we're trying to compare. So you want to make sure that all of your stairwells, at least one of them for sure, is wide open, propped open, and has a direct path all the way down to the first floor, and that door is propped open. So my goal was to really get outside pressures as I'm doing these types of tests. So as you can see,
Hey, Joe.
yeah, sure, good, go.
On that tubing hookup for that, the chances of people getting it right based on the theory is close to zero, really. They really have to take a look in the current version of the manual, and I show exactly where the tubes have to go in all cases with color coding on both gauges. The other thing I wanted to mention is that some of the manuals in the handouts were 2 years old, and I've just replaced them with the current versions. The software manual was a 2013 version. We have a 2015 version, probably 15 versions since old. So I've updated all those. So I would suggest that everybody re-download the handouts because I've gone and changed them all. I've also added into the handouts the air leakage testing protocol for the U.S. Army Corps for someone who asked for that. That's in there. It's not actually on our website. It needs to get on there. So that Army Corps protocol is now in our testing procedure. What else did I wanted to add? So I would suggest you re-download them and check the dates. There's always a date on the top right-hand corner of every manual. So year, month, day. So those were the main points I wanted to make.
Oh, great, thank you. So someone chimed in that some code officials do allow a neutral pressurization. We're trying to actually change the language because we felt that the term guarded was a strange term, but really what you're doing is you're creating a neutral pressure. So we're trying to alter the lingo to neutral pressure. So it's the same as guarded test, but we think neutral pressurization is a much better accurate term. So somebody says that most code officials would allow you to do a neutral pressurization test. I'm sure it depends on a lot of things, your jurisdiction. So here, what we're trying to do is test this unit. We'll call it Unit B for this sake, and it's on the third floor. So when I first do my blower door test, I'm pressurizing, and you can see on units A and B to the side of it, I'm able to actually open up a window or a door that allows me the ability to allow a pressure relief on each side of it. So, and I've also went ahead and cracked open, which you don't see in the illustration, the door on the top, so it actually goes to the stairs and goes all the way outside, and that's also propped open. So after I did my first test, I got 1200 CFM as my reading for this individual unit. So some tests may say, okay, this unit leaks 1200 CFM, but I can now try and isolate that as to what side may be something I should be focusing on correcting, or what's really only my leakage to outside, maybe another test that also is part of a compliance. So here's my first test where I have 1200 CFM, blower door, pressurizing, and you can try and give you an illustration as to where all of the air is trying to move to, and my goal is to isolate each one of these pathways. So for my next test, what I can now do is actually bring a blower door in and pressurize the stairwell or the hallway. All right, so the hallway is now pressurized. So I've neutralized the air movement that can happen between the unit and the hallway. And I make sure I have all of the stairwell is completely open all the way down to the ground, so I'm able to access and have plenty of airflow throughout the stairwell. Notice that my connection between the unit and the hallway was approximately 100 CFM because I went down to 1100 CFM. So here's an illustration showing that I now have pressurized the hallway with the blower door, and so now I'm actually going to do the unit on the right. Now, depending on if you have this nice controlled hallway, and on the far end, I actually have closed the door. And but if I'm able to get enough pressure out of the hallway, that I might be able to just open the door to the unit on the one side and on the right. And once I do that, I have to make sure I seal the windows or any other conditions, you no longer need a pressure relief on the other side. This is just really only focused from one side from the area that I'm testing. So I still have a pressure relief on the left. So once I open the door here, then I actually have been able to create a neutral pressure on the right side. So now I have the hallway and the right side with neutral pressure, and my number went down another 200. So now I have 200 CFM that's connected between that common wall. And here's a 3D kind of illustration showing that setup. So again, the door's open on the right. The pressure's gone into the room on the right. I no longer have any leakage over there. I could have some in the interstitial wall, but I have nothing that's going into that unit itself. And if your units are small enough and you have a good seal in your hallway and you're able to do this, I can open the door on the other side of the unit and now actually have pressure on both sides of my central unit B that I'm testing, and my only went down 50 CFM to the unit on the left. So I know that there's not a lot of connections between the unit on the left. And here's our 3D illustration. Now, if I did not have a common hallway or was not able to make sure I had enough pressure to neutralize that, then I might have to actually put individual blower doors in the units themselves and just kind of move that blower door around from unit to unit. Which I have to do now, actually, if I want to kind of isolate what's happening above and below in terms of my leakage. So some of the places I tested in New York, I found that the unit to unit was actually pretty fine. It was actually their chaseways that they had that were their greatest issues, that had a lot of air movement through their mechanical systems from behind their plumbing chases or their plumbing walls and others that just allowed air to move freely through all the floors were really the greatest issue. So I went above and I actually was able to lower it another 100. So I now know that I have 100 CFM leakage between the unit above. And when I also can do the unit below it, I can kind of get a conclusion as to maybe it's another 100 from the unit on the bottom. So maybe this unit, instead of leaking 1,200, maybe it only leaks 650 CFM. So if your local jurisdiction allows you to do a neutral pressurization test, it can allow you to actually get a much better chance of compliance to do some of these small unit testing to confirm that you are actually in compliance with an air change per hour, which can be very challenging for these small units. I'm going to move on to some software. If there's any other questions, I'll scan here quickly to see if there's anything else. Someone asked, do I log in the difference? Do I actually log in the difference when the units are open or closed? I don't really do that actually, because I'm actually wanting to make sure that the pressure is relieving on the adjoining side that I'm testing. Once I have that, then I'm either going to allow pressure to neutralize that as the next step, but I don't actually keep track of what the pressures are different from whether I close or open the windows. So some of the software that's out there that allows you to do some of these tests is fantastic. So on the picture on the left here is I was in New York about a year and a half, and had a unit where we had multiple floors to run around and do some testing for one day. So we had a lot of fun doing that, and realized that many of their units were very tight. It was actually some of their chaseways that actually had compromised their entire structure. So Fantastic is a great source of being able to do more of the whole building testing is what it's designed for, but you can set it up to do any type of individual test that you need. It actually has the ability to be flexible to alter your parameters. But if I was going to test this entire structure, I could literally open it up, ask it to find the gauges, and hit go. And it would actually perform the entire standard test that I needed to do specifically for that standard and create a report. So for that aspect, it's a phenomenal resource and a great piece of software that Retrotec has developed. You can go online and download Fantastic for free. There's different versions, whether you want to use the Pro, which actually it's 2 fans or 6 fans or 24. And the one you download for 30 days will kind of do everything for you. So it's a great resource that's out there. You can download it and give it a try. So I definitely encourage you to do that. We have other webinars that are specifically about Fantastic. Another great resource, which is one of the things I was using when I was in New York, was just a simple virtual gauge, which says, "Hey, what are my fans doing?" So I could actually have these two fans there. We were actually had to move fans around from unit to unit. So I can say, "Oh, here I'm doing this one test," and I could determine that this was the unit that I was testing, and then the other unit that I was isolating. But you can do as many fans as you want with Fantastic. So it can actually open up multiple fans at one time, and actually I can see exactly what's going on. So at one time, we were able to do a test where I had the unit being pressurized, the units side by side being pressurized, and even one above. So it was a great resource to do that and see them live. The situation here, though, is I have to write down my results. It doesn't actually do any kind of documentation except what I can see live. I also, when I was in New York, I did do this a lot. I was using the data logger because of its simple flexibility, where I can use multiple gauges and fans to just log what runs through it as a resource. So I can do it with Wi-Fi or through wired connection. If you really want to make sure you get good connections with Fantastic or with the data logger, I highly recommend you just use wires. Just use the cables. Usually they're close enough that it's never an issue. But sometimes there's little glitches that happen in Wi-Fi that we don't really are aware of when we are watching stuff on a screen or surfing. But your data will have little gaps when you have Wi-Fi. So I highly encourage you to think about just using a solid connection. Depends on what you're after. When I'm using virtual gauge, it's not really identifiable that I may have had little gaps. So I would definitely encourage you to do more of a wired system. So when I stop logging on data logger, I get the great information. So right here I have 4 fans being logged at the same time. 32, these are the serial numbers, 32, 94, 55, and 04. And you can see them being repeated all the way down here. So whatever interval I asked it to capture data could be half second, 1 second, every 5 seconds, or whatever it was, even 30 seconds. It actually goes to those gauges and grabs that data. It tells me a couple of great things about it, like what range it's on, and if I change the ranges, what was the pressure on channel A and channel B, and what my results were. So you can kind of see things kind of ramp up. And these are also what's in the gauge. What were my actual results that I wanted to do in the gauge? So a couple other screenshots here to kind of show you that, once I know all of these factors, or if somebody had changed the range and changed the range on the gauge, that would also show up in my results. So here you can see an example of this is one fan where I changed my range, and over here on the far side, I'd actually had changed my results. So instead of doing CFM, I had air changes per hour or CFM per 100 square foot. All of the things that are in the gauge all get logged through Data Logger. Data Logger is a free software that you can download and run on a PC. It's very similar, kind of like the configurator. You can just open it up, select a few criterias, and hit start logging. And once you start logging, anything that's happening through the gauge will get captured. And then when you hit stop, it will create this spreadsheet. All right, I got a few minutes left. I had these slides in about equipment just so people can get an idea of what were some of the options for doing some of the fans. So I'll kind of move through it kind of quickly. So Retrotec has multiple fans. Some people have the middle one, which is an older style, and the 1000 is the been replaced with the 3000, and that's about how many CFMs each of these does. So there's also now a 5000 that's out there that is more of the commercial style, but uses the smaller shell, which makes it a lot lighter. So these are, if you're going to buy a unit today, these are the units that you would purchase, and some of the different ranges that they have. So the 5000 and 6000 are just upgrades of previous models, but they really went to a whole nother level of doing the ranges, so that you only have an A and a B, and then you actually have the flow plugs. So I may have now a B 6 or 4, depending on how many of the flow plugs have been removed. And it makes it universal because these plugs or openings also work with the duct testers. So you can actually go down to a smaller single opening millimeter and do around, say 5-10 CFM of a unit with a blower door. So that's incredibly tight situations that you may have for some of the homes that are achieving these remarkable numbers. We did talk about the calculator already. Their frames snap together. Again, this is a Retrotec webinar, so I feel that it's reasonable to try and show some of your options that are out there, from the basic fan in the middle to the passive house on the left, or they have a very large oversize. And notice that even for the basic model, you're getting 2 crossbars to help support your system. And if those that do a lot of these types of testing, they love the modular panel. This thing actually snaps together incredibly quick. All goes back to a case. We'll work with almost any fan they have right now, but these things are amazing. Now, they're not the tightest in terms of leakage that happens through them, but they are the most amazing and universal that is able to be quickly set up and moved to the next job site. If you're doing something that is critical in terms of air leakage, you may want to be considered using the passive house in a window unit, because it's probably that small of a structure anyway. And for those of you that do large buildings, there's also a folding panel, which actually folds and has different support methods of holding it from the outside. And this is the thing that most large building users are actually doing in the field. Sometimes they actually have to create their own actual device to hold all of the fans. So here's a 24 fan passive house mall being tested in Europe, and it did pass. Larger is not always better. So some folks went with the super large mega fan, only to realize that they were not able to get the amount of pressure throughout the structure from one small opening. It may work great in an airplane hangar, but they found was really a struggle to actually get that much air moving through the entire structure at one time. Here's my last plug for the blower door training, multi-fan setup, where we will focus on how to do some of this compartmentalization test, how to understand some pressures, how to use and set up Retrotec equipment, and a variety of details. That's really what we want to focus on. It's a one-day training. If you want more information about that, you can go to retrotec.com or send us an email. Colin, you got anything you want to add?
Yeah, I got to turn everything on here. Yes, got a few things. I just realized for those people in Europe, there's this horrible change from daylight saving time, and they change to daylight saving a different time that we do, so times get messed up. The sooner we get rid of daylight saving, the better, as far as I'm concerned. But yeah, a few points I wanted to touch on. First one is, when we're talking about air changes, even in large buildings, air changes is, even at 50 pascals, is a figure that's useful for looking at ventilation rates and building performance. Whereas flow per unit area, which is typical of the U.S. Army Corps spec and so on, is really a measurement of how well the enclosure itself is constructed from an air tightness standpoint, or how well the air barrier is constructed. So they have different purposes. One is performance of the building in actual real life, so to speak, and the other one is the performance of the air barrier itself. And in the Army Corps protocol, there's 2 options. One is to leave the building as is with exhaust fans and so on in their unsealed condition, if they're intermittent, to see how the building performs on a day-to-day basis. The other one is to seal all the intentional openings up to see how well the air barrier was constructed. So there are many different reasons why we would do this test, and the building would get set up differently for those different tests, and sometimes the results would be different to reflect that different test as well. So that's my first point. Second point, Joe touched on the ABAA standard, which is the Air Barrier Association of America, which oddly enough their office is in Winnipeg, Canada. Originally, the U.S. Army Corps protocol was primarily written by me and a few other people, and came out about 3 or 4 years ago. The committee decided they wanted to clean it up a bit. That took a year, and it's still essentially the same as it was before. From there, we started writing a complete large building testing standard that we eventually wanted to turn into an ASTM standard. That has been going on for 3 years now. We've been meeting for 3 hours a week for 3 years. Most weeks in order to get it there, and we're still probably at least a year off from that. The next point would be, there was a question that someone asked about stack effect and door openings and pressure balances when testing whole buildings. We have an Excel spreadsheet that does a very nice analysis. I created originally when someone was doing a 30-story test and was concerned about stack. It will demonstrate, if you're testing to 50 pascal, that you can actually tolerate as much as 50 pascals of stack on the top of the building and still get decent results, provided you test in both directions. The spreadsheet will tell you exactly how a building will perform before you go out there to test. And one of the key inputs is the number of square feet of opening you have from your test floor to the rest of the building. The other key input would be the maximum amount of stack that you would expect on the day of the test. Armed with those pieces of information, we can tell you where the fans need to be located in the building. In this case, we had to open up one of the elevator shafts to get to the air to the upper floors, and when we did so, we had the same pressure in the building within a few percent. So if anyone has that test, I can send you a copy of that spreadsheet and we can work through it. And the final point is on the data logger. Joe and I kind of disagree to a certain extent on using the data logger for large building tests. It's a great way to log pressures for a variety of different reasons. If I want to see how something performs over time, I'll put the data logger on it for half an hour and I'll come back and I'll take a look at it and it'll show me the characteristic pressure. As far as building testing is concerned, though, the fantastic software is designed to perform a test according to any standard. So you select the standard, you press go, and basically without knowing much of anything, you can perform a compliant test. All the defaults are set to the values that the standard tells you to set them to, so you don't have to spend hours and hours studying the standards to do a compliant test. So those are all the points I had jotted down, and we're certainly happy to take additional questions.
I'll defend my data logger. So the only time I felt the data logger was valuable was I was doing something that Fantastic may not actually be set to do, and that is to do something that was more of compartmentalization, where it wasn't a standard, it was just to do a test. So you could use Fantastic to do that, but my goal was to just kind of like log, okay, I'm at 50 here, and what are my pressures on the units next to it or not. So sometimes you'll find they have different solutions depending on the application. So, but in terms of if you're testing to a standard, there's nothing better than Fantastic to actually just set up and hit go and do everything that standard required and let you know if you forgot something and make sure you completed that.
There was also a question about how we seal above the door closers, and in some cases it's easy to take them off, and the aluminum frame and cloth, the only real option with door closers is to kind of take them off or to put the fan in another part of the doorway where you can get the frame to grab hold of it and get around the door closer. The hard panels, of which we have 2 or 3 different models, are quite different because you can bring the hard panel up to the door closure and then use a piece of grill mask or tape to tape over that hole. So the hard panels are much faster for testing large buildings, which is the reason why we use them. The other main reason that wasn't mentioned is that we often have to go in and out of doorways numerous times. So we can pop the hard panels out of the doorway in a second and pop them back in 2. Whereas if you're going through a cloth panel, you pretty much have to try and pull your body through the cloth hole and try not to take the cloth with you. And it takes much longer to reinstall the panel, whereas with the hard panel, you can actually duck through the hard hole in the panel or remove the bottom panel very quickly. So it makes moving around and pass the panels much easier, which is one of their big advantages. Anything else out there? You still with us, Joe?
Yeah, I muted myself so I wouldn't cough on everybody. There was one question here about the volume and housing calculated with or without a false ceiling. So I was trying to answer that question. I'm assuming it's based upon the standard, but you should include the entire volume.
Yeah, we're really looking at the volume to the air barrier, which is either inside the wall or on the wall or whatever. So the wall that faces outdoors. I like to use the term outdoors to mean the difference between like where it rains and so on and where it doesn't. Outside can mean outside an apartment, inside a building, in a hallway. So that can get confusing. So we try to use the term outdoors when we mean outside where it rains and snows and so on, so that there's no confusion there. And for those of you that missed this video, in a week or two it will be on our website under, if you look under webinars, past webinars, you can see it, or you can do a search under videos. Probably easier to find it under webinars, and there's a little button for past webinars. So it's all there. And by all means, if you have other questions, you can just email us at support@retrotec.com, and we're happy to answer them as best we can. The question that Cohn Hoff was asking about how many fans, the method of calculating the number of fans is fairly trivial actually, and our fan calculator does that quite well. What's probably more difficult when you're using multiple fans, like say 2 or 3 fans or more, is to know what pressures will be inside the enclosure and to know where the fan should be distributed. So you might need to use additional fans just to get the proper pressure in different parts of the building. So that becomes more complicated, and the spreadsheet that I mentioned earlier answers that question fairly well. There's a question about certification. We do have a large building certification currently, which I have to admit is in need of updating, but it's still a lot of useful information there. And I don't know if you have anything to add to that, Joe?
I think he was referring to the live training.
Okay.
Yeah.
Oh, sounds like that's about it then.
Somebody did ask about the upgrade, which I'll just drag over here real quick. So I didn't have it in this set of slides earlier, but someone asked about the upgrade that many people might be debating on upgrading their gauge. So Retrotec does have a buyback program or trade-in program where you can trade in your DM2 or the DG700, a little bit of money, and you get a brand new DM32 smart gauge. So it's a great price and a no-brainer if you're thinking about. And you can actually use the DM32 to run your existing energy conservatory fans, duct blaster or lower door. There's a little adapter that you get that changes the signal from Retrotec into Minneapolis, and then you can run it just like you do the normal fans for Retrotec. So if you are interested in that, you can definitely contact support@retrotec.com. Someone asked about in the beginning, there are multiple slides we need to go through in order to make sure that I cover some of the requirements for Retrotec and from BPI and other stuff. So that's all I can say is I appreciate it. I try and move through them quickly, and they're a necessary evil. So anyway, we appreciate everybody's time. Any other last questions?
Yeah, there was one where someone asked about our upcoming live trainings. If you go to our website under support, I believe, there's a section in there that says live trainings, and they're all listed in there in chronological order. I think it's under support, isn't it?
I'm looking.
No No, it's under training, oddly enough. So we main category is products training. It's the second category, and in there, there's on the second row, it says live event calendar, and in that calendar are all events that we're going to, either we're putting on or someone else is putting on, and you can do a search for your geographic area. So go to the website under training as a main heading, and look at live events, and there they will all be. Oh, I don't see any more questions, so.
I think it's a wrap. Everybody, thanks a lot for joining us in. We will be back next Thursday, I believe, with our next webinar. And I appreciate everybody's patience. I had a real bad cold, and hopefully it wasn't too agonizing to hear my voice. So anyway, everybody,